Hey, I'm Gale Banks. I'm here with Matt, the Motorator D'Andrea, out here with his 95 Lightning, and preparing to have some fun on the dyno. So
yeah, I'm
tell
excited
us about the
this.
Lightning.
Oh my gosh. This has been such a fun project so far. Well, it got kind of built up on the show and on social media, and everybody reached out and said, you should do it. You should get a Lightning. So I went out and got it. And you know, I'm a fan of Ford's SVT cars back in the day.
Exactly.
I had two 93 Mustang Cobras. Well, I owned one in 93, and now I have two of them now. They're all highly modified. So here, we're going to be putting this thing on your dyno. We're going to get some baseline numbers, but not just the horsepower and torque numbers, all sorts of data that you're a super freak about.
Okay.
Air temperatures and densities and RPMs and all the good stuff.
I see forced induction. You got my attention.
All right.
There's a blower on this thing.
Right. Okay. So why don't we do this? I'll walk you through the truck a little bit.
All right.
And then we can get into what's good and what's bad.
Let's do it.
Mostly all the bad, and then how we're going to fix it.
We'll make it
this
good.
truck here is, again, 1995 Ford F-150 Lightning. It has a 5.8 liter. It's a 351 Windsor.
Right.
It has a terrible speed density fuel injection system. It wasn't even mass air at the time.
Yes.
A lot of guys did a mass airflow conversion. But when this truck came out, Ford Motorsport had teamed up with a company called Powerdyne, which I believe were former Paxton Supercharger employees.
Or Vortec.
Yeah, or, well, this is before Paxton and Vortec were the same. It was early Paxton.
Yes.
And they created a Powerdyne Supercharger.
They were in Lancaster or somewhere like that. Yeah.
So this Supercharger is a Ford Motorsport Powerdyne Supercharger, but inside here is not gear driven, it's belt driven. There's a belt inside here.
So this is to speed up the centrifugal compressor way above crank speed. So, so the damn thing will work.
Now, it was never meant to be a high boost system. It was meant to be a low boost street system around 5, 6, maybe 8 PSI, depending on the pulley size.
Well, I looked into it a little bit.
Yeah, there's not a lot of information.
The EO found the executive order. It's smog legal.
It is.
Yeah.
Probably because it just generated heat.
6.5 pounds of boost.
Yeah, okay.
So, yeah.
So,
we'll measure that.
Okay, so the guy that bought this truck new worked at the Ford dealer in Montana, I believe, and he immediately put this on. So this is a
he
dealer
was at
installed
high
item.
altitude. He needed air density.
He needed it. There was losing horsepower
he was
up there.
Starving for air density.
So this truck has 99,000 miles on it, and I think this thing has been on here for 99,000 miles.
Good, reliable supercharger. What was the factory horsepower?
So the factory horsepower is 240 rated at the crank, and I think the torque was 370 or so, somewhere in that range.
Yeah, that sounds right. 370, 380. Yeah.
And when guys were getting these new, putting them on the dyno, they were making about 195 of the tires. Now
that sounds logical too. That's quite a bit of drivetrain loss.
Yeah. Well, as these things get tired, they probably make about 475, 490. But I don't know what this is doing. So we're going to find out from you. Is this adding horsepower or just generating more heat than anything else?
It's generating heat, I can almost guarantee you. What's the RPM at the horsepower peak? Is it a truck like?
Yeah, it's
4,000, 42, 4,400, somewhere in there?
Because I think the peak on this truck, peak RPM, based on its cam, is low, 4,800, maybe 5,000 max. It was about
peak
3 or 4.
RPM,
Yeah,
not the horsepower peak.
Not the horsepower peak. It was about 300 or 400 less than what the Mustang Cobras were. They were maybe 5,200 or so. Yeah. So I think this comes in like around 4,900 in the peak RPM. And you're right, probably in the somewhere in the low 4,000s.
Yes.
Is peak horsepower.
What really feels good, we're talking about peak horsepower. This thing has a lot of torque relative to its peak horsepower, 240 versus say 380 or so, which makes them really have good mid-range horsepower. So when you pedal it a little bit, you feel it.
Yeah.
If the blower's done the way I would do it, and this being a pickup truck, even though it probably has no tow rating whatsoever.
5,000.
Okay, 5,000 pound tow
Because they did
rating.
that specifically because they wanted it to tow more than the GMC Cyclone. A truck that I know you were involved in back in the day.
Yes. The backstory on all this, just in a nutshell.
Yeah.
In '86, a guy named John Rock took over GMC to build it up. And he approached me to create a sport truck image. What would you do with a truck?
Right, sport trucks were coming on.
Yeah, out here in
especially
California.
in the West Coast.
So I met him at the International Truck Show for breakfast in Anaheim, and he laid it all out. And I said, well, I do something remarkable with a pickup truck. Let's go 200 at Bonneville. Basically, he said, create a proposal for that and give it to me. So I came home. We generated styling drawings for the truck with the help of David Stollery, a fellow that's taught at Art Center and started it. He founded the California Toyota Design Studio in Laguna Beach. Stollery gave me some renderings on the truck with a wing on the back, just stuff I wanted to do. And we plugged one of my twin turbo boat motors, 454 Chevy, under the hood, gave him the styling drawings on the engine as well, and he bought it. And he said, let's talk about building it. Talked to corporate. The Chevy guys said, hey, if anybody builds a standard cab, short bed, big block performance truck, it's not going to be GMC. We've got like 85% of the corporate truck volume.
Yeah.
We'll do it. You do an S15. So we did an S15, ran it at Bonneville in '89, went a best of like 198, 199. I was tagging the pistons, but we almost went 200 with a little 300-inch V6. The next year, they wanted to come back and go 200, so they loosened up the control of what was done to the engine, and we went a best of 210 with the damn thing. That's the Cyclone.
The quest for speed is almost as old as the auto industry itself. And for more than 70 years, the place to race flat out has been the Bonneville Salt Flats. So it wasn't surprising that when General Motors Corporation set out to conquer a new speed barrier, they came to the Salt Flats. But it might be surprising that the vehicle they brought was a mini pickup. Surprising until you realize that the biggest selling vehicle in the U.S. isn't a car, it's a truck. And truck buyers, like car buyers, are becoming more performance-oriented. So truck manufacturers have taken notice. Last year, this GMC S15 pickup set the record as the world's fastest pickup truck. This week, the team from GMC and Gale Banks Engineering returned to set new records, and for the first time, to break the 200-mile-an-hour barrier in a pickup. The team continued trying to push the record even higher. Unfortunately, the weather did not cooperate. High temperatures near 100 degrees and strong winds held speeds in check until one dazzling run at more than 210 miles an hour. Combined with a wind-hampered previous run, they were able to push the record average over 204 miles an hour, presumably where it will stay for the foreseeable future.
So Chevy came out in 90 with a 454 SS.
Yeah.
92, 93, they came out with a Cyclone production truck. Ford's answering fire in 93 was this truck.
So your original proposal was to GMC for a 454 truck.
Yes.
Chevy ended up taking that to build the 454 SS.
Well,
and
they
then you
saw
guys,
the drawings. What?
And then you
know.
ended up building what became the Cyclone
Exactly.
for GMC because
Yes.
Chevy didn't want them to have the same size truck.
Right.
Right. Okay.
And in 93, this was to counter the 454 SS and the Cyclone.
Yes.
This was answering fire. These couldn't beat a Cyclone. Cyclones were all-wheel drive, turboed V6, and they were quick as hell on the street. They were quick with all-wheel drive. They were quick in the rain.
Yeah.
0 to 60. Amazing little truck.
A good friend of yours, Jay Leno, has a Cyclone, and I don't know if you've ever heard his story about
the Christmas tree story.
Yes.
Yeah.
So Jay Leno has a Cyclone, and
you gotta hear this.
He wanted to get a Christmas tree one year long ago for Christmas, and I believe the Cyclone was brand new at the time. And there was a GMC dealer across the lot from the Christmas tree lot. So he walked over in there and said, "This is the tree I want. Bring it to my house. I need it delivered." And they said, "We don't deliver." And he said, "Okay." He walked across the street, bought a GMC Cyclone, brought it over there, loaded up his Christmas tree, and brought it home. And he's had it ever since. And if you ask him now, he says, "That's my rainy day car."
Yeah,
because it's the all-wheel drive.
Yeah.
And it's, you know, it's not $4 million.
Yeah, they were affordable.
Yeah, they were affordable. I wish I could do that. I just need to haul a Christmas tree.
It's
I gotta
a
get
very
used
low
truck.
mileage Cyclone, I'll tell you.
Yeah, I think he uses it for Christmas. I don't know. Maybe that's it. Maybe it's just his Christmas tree delivery vehicle.
Yeah.
So this here, we have a lot of plans for it, but I thought it would be important to start getting all of these baseline numbers first. You know, we want to get horsepower and torque and things like that, but start looking at the temperatures and what's the supercharger doing and what's the temperature, what's the transmission doing at this point. And then I want to step up to a 427 small block.
Okay, now you're
with
maybe.
I want to put in a 4-bolt block, 427 small block, and we're probably going to end up taking this supercharger.
So you want
off.
to beat Cyclones?
I want to kill those Cyclones. You know, it was funny because I think the Roush guys just came out with their truck called the Nightmare, and they said, fastest production truck you can buy. 650 horsepower, 0 to 60 in 3.9 seconds. I say, challenge accepted. We're going after that. I want to put a big Pro Charger on that, like a big T1 SC, and see if we can get, I don't know, 600-700 horsepower out of it.
Okay, we're going to baseline this critter.
Yeah, I'm excited.
Well, I'm going to follow the airflow through the nose of the vehicle, to the filter, to the compressor, out of the compressor, and into the intake manifold. And we're going to even measure temperature and pressure in the manifold plenum, feeding the ram tubes. So what we're following here is air density. The engine's horsepower is determined by the density level we can achieve in that intake manifold. There is an inherent problem with this engine, and I looked up the executive order, the smog Ford
on the supercharger.
Yeah. Even though this one is it branded Ford?
Yeah, Ford Motorsports.
Okay, this is the Ford Motorsports Supercharger. It has a smog EO from California, dating, I think, around the early 90s somewhere. And it designates 6.5 pounds of boost. It also, I have found that when it goes into boost, it retards the timing from where it should be to 9 degrees before top dead center. That's hugely retarded. Guys used to call that boost retard.
Yeah.
The engine is rated for 92 octane, which you cannot buy in California. But you're running on, what are you running on?
Yeah, well, I only put 91 in it, but I've only owned a car for a month.
Okay. Well,
who knows what they put in it?
Don't put anything less in it.
Yeah.
You're already edgy. Why are they retarding the spark so much under boost? They're doing it because they're heating the air.
Yeah.
And that raises the detonation threshold. So as it boosts, you're pulling out spark and diminishing power while you're making power. That's not how it's done. You want to put in boost and leave the spark where it's at.
Right, but the only way to do that would be to add some sort of intercooler, which we don't have.
Well, it needs more than an intercooler, I'll tell you. Just looking at it, just to walk through it, ambient air out here versus ambient air in here with the hood closed is going to be at a lower pressure and much higher heat. So the air density, the pounds per 1,000 cubic feet, the pounds per 1,000 is like 70, 72 here. It's going to be less here by the time, and you're just getting the air to the air cleaner, and you've already lost power potential. Into the compressor, depending on its efficiency, is going to heat the air and boost the air. It's going to have to do some to make up what happened here in terms of boost. The only way to make up for this is some boosts here. We're measuring temperature, pressure, and humidity out here in your grill is one of our air mouse ambient sensors.
Okay.
That will give us the air density out here. We're also measuring it going into the compressor, temperature and pressure. That will give us the air density loss through this, because there's going to be a pressure loss through an air filter.
Right.
So we're going to have the density out here, the density right there, the density at the intake to the compressor. Then we built you a new boost tube.
Okay,
and we put temperature and pressure there. So that's going to be the density gain across the compressor. And then we'll follow it all the way down into the plenum over there.
Yeah.
And we'll give you the density level there. There's going to be a little loss getting to there. So those are our metrics. If we add an intercooler, then we're going to measure out of the compressor and out of the intercooler.
Right.
See what the intercooler is doing.
Basically going through on both ends of the intercooler.
This is technology. This is an 8.8 to 1 compression ratio.
Yes.
Back then, that was soft. By today's standards, it's really soft. Guys they're turbocharging engines from the factory
that are 11 to 1.
Yeah, 11 to 1 or slightly more.
Yeah.
So,
but now they have more sophisticated NOx sensors and everything else.
There is no NOx sensor here. Just like it's on the street. All right. Here we go.
So we just did a little bit of research, and we knew it was 240 horsepower rated by Ford at the crank. It's 340.
So we're both wrong on the torque.
So it's 240, 340.
Okay.
240 horsepower, 340 pound-feet of torque.
Yeah.
And the only real dyno test that I found from back in the day had it about 195 horsepower at the tires.
Okay.
And 270 pound-feet of torque at the tires.
Okay.
So 195, 270
That's
is what
our
we're trying
goal.
to beat.
Yeah. Here's what we've got. This is really surprising.
Not surprising in a good way.
Well, we've got a little correction factor today.
Yeah.
We'll apply that. But basically, we got about 69.5 pounds per 1,000 cubic feet ambient air density. We'll correct to the standard day definition, which is 72.2 pounds per 1,000 cubic feet. So here's the uncorrected number on horsepower, 196.9. We'll call that 197. And with the correction factor, 203.2. Okay. So that's what you can compare to Ford's number.
Right, so
or that
Ford's
190
number, was about 195.
Chassis dyno number. So,
and we're at 203. So the Supercharger
8 horsepower
is 8 horsepower.
Yeah, okay, but it gets better.
That's money well spent.
So the torque, that dyno test was
270.
270.
Yeah.
Chassis dyno. We're at 334 rounding off, uncorrected, and we're at 344 corrected. That's a big boost in mid-range torque and a big boost in mid-range horsepower. I wish I had the horsepower and torque curve from that dyno test. But what tells me it's a really big boost is the horsepower peak is no longer at 4,200 RPM, it's at 3,100 RPM. So what's happened here is we're looking at the peak numbers. We'll go back and we'll look at the horsepower curve. But I'm telling you, the torque at that horsepower peak is going to be up there, and the horsepower is going to be up there. So what this does is it gives you drivability in the mid-range. But the blower is killing potential top end. We'll see if the shape of the horsepower curve will tell us that. And I will bet the torque peak moved downscale as well.
So
that blower made the engine real efficient
In
at the
mid-range.
wrong, well, it could have been a nice spread. But the reason the horsepower peak didn't go up much is twofold. It's 1100 RPM early,
Okay.
and that's cylinder cycle rate. CFM engine is a lot less here than it is at 4200.
So when you drive the truck, it feels, obviously it's an older truck, it's a 95. It feels a little quicker than normal, but that's because of the 75 extra pound-feet of torque that
Well, there's
we're feeling.
that. And it's filling in the torque curve and thus the horsepower curve right in the mid-range.
Now, is that horsepower, like we saw the initial dyno numbers on a stock 95 Lightning at about 195. Is that 195 at the end of, it's probably at the end.
That will happen.
And now we're kind of maybe getting horsepower sooner and flattening out.
We're actually guessing.
We don't know.
We'll pull the card, we'll go through the data, we'll chart and graph it all. I'll send you a copy and we'll get on the phone and talk it out.
Yeah, we'll figure it out. We'll figure out why we made 8 horsepower and 75 pound-feet of torque.
Yeah, and what the hell happened to the horsepower peak?
Yeah, where did it go?
Where did it go?
It's
This is going to be very interesting.
Thanks, Gail. So what did you think?
Well, I'm a little depressed. I think I've seen the worst supercharger of my life.
That's right there?
That thing right there.
That's so sad.